Hello, good morning, students. How are you? After 4 days, we are meeting in this platform, and you all are ready here for the learning. Today, I am going to start a new chapter of your first volume of the chemistry, that is the surface chemistry. And this is the chapter where you have the guarantee of the scoring marks. Whenever we are teaching and we are learning, what happens actually, our first target is always 23 marks, and after that quantity, the quality is being added into it. For this 23 marks, this is one of the most trusted chapter of the all teachers as well as of the students. Not a single student I have seen that he is not able to understand this chapter or not able to score in this chapter. So this is one of the best chapter. First for setting the goal of the 23, then after that barrier, I think I'm just reminding you the last chapter with my conversation that there is a threshold barrier level of the 23. After that, the quality is being added there. So for this is such a wonderful chapter, the very easy chapter, the simple one. And why I started this chapter? Actually, you all were demanding about the electrochemistry, and I also planned that. But some of the students I have seen, they were not connected. They were even not able to develop the repo. So I took this small chapter, 3, 4, maximum, but the 5 classes, this chapter will be completed. And I feel we will have a better repo. And if we will start learning chemistry, if we will start understanding the chemistry, definitely it will be easier to understand the electrochemistry. And meanwhile, we will get sufficient time to do the practice of the chemical kinetics numerical questions. And because of this, I just taken this chapter, and definitely everybody is going to cross the barrier of threshold 23 marks with this chapter. For the competitive purpose, the questions, very simple question is asked from this, right? This chapter consists mainly 4, 5 topics are there. Adsorption, along with the adsorption, here we compare it with the absorption also, and along with simultaneously we learn both the terms adsorption as well as the absorption. Catalyst, most of the its part I have explained in my previous class when I was checking the chemical kinetics effect of catalysis on the rate of reaction. The next one is enzyme, another very smart topic, especially for the bio students. Colloids, some of you know, class 9, we have studied this topic, colloid. From there, I'm going to take it. And one specific example of the colloid emulsion. These are then metallics, some small topics are there that we are going to learn here. The type of question is the theoretical questions. This is a chapter of the physical chemistry that gives you the theory-based questions. Sometimes some of you are not that much comfortable with the numericals. So for this is the best chapter. You know what I prefer? I always prefer to teach and learn both, from simple to easy. So this is so sweet, so smart, so simple chapter. Very easy to learn, very easy to write during the examination. Generally, a 3-mark question is asked from this topic, and that 3-mark question is generally divided into the 3 questions of 1 mark, 1, 1, 1, 3. This can be the marks distribution, right? So very easy chapter, and some chapters of the volume 2 and some chapters of the volume 1, they give the guarantee of the 23 marks. So very nice chapter, very easy to understand. And let's start with its name, surface chemistry. That means chemistry of the surface. Surface means interface. This is one, and here I am keeping my hand So what happens between my palm and the board? This is the chemistry that we study in the chemical, in the surface chemistry, right? Some more, somewhat related with the physics type of the topic, right? So this is the topic, very simple topics are there. So surface chemistry is the branch of the chemistry that deals with all the phenomena which take place at the interface of the two objects, two species, two chemicals, I will say, for the chemistry language, right? So that branch is the surface chemistry. The one very important topic from where we have to start, already I have started. I think you all can read something is written on the board. And this is just possible because of one phenomena that we are just going to learn here, just we are going to understand here. That phenomena is the adsorption. Right? So which topic I'm going to take? I'm just going to start the topic adsorption. Visible? Is it legible to all of you? And I'm audible, I think, to all of you? Yes. So adsorption, how you will define it? What is this phenomena? What I did here? Before few seconds, the board was the green one, and I have added the white color onto this. This is the adsorption, right? Whenever onto one surface, this surface is generally solid, maybe liquid also, right? When any other material, right, it sticks over, it is added here, it is retained over here. This is the adsorption, right? You all can see the wall is painted. This is one very simple example of the adsorption. Was it before like this? No, earlier it was made up of the brick cement, and that was the texture of the classroom. But after that, a layer of a beautiful color is deposited over this surface. And this deposition, this is exactly the adsorption, adding of something, right? That is the adsorption, right? So one very simple how you can define the term adsorption. The word adsorption, the term adsorption means adding up of any of the object or any of the molecular species onto the surface, right? Please, the very important thing is this is on the surface. If I cut this wall, okay, sometimes you scratch, you are very naughty in the classrooms, even to your furniture, you are scratching, you are doing such things. And what you see, the inner surface is not the same color because it is deposited only on the upper surface, right? It has not moved inside, right? It has not penetrated inside, right? This is the adsorption. Simultaneously, I think I must take the word absorption also. How many of you like the gulab jamun? I think most of you. Mouth watering. Then rasgulla, another favorite one. Jalebi, morning breakfast, poha and jalebi. One of the most favorite breakfast. What happens there? Does the same story is like the absorption in that? No. Whenever you cut a small slice of the rasgulla or the gulab jamun, what do you find? The sugar syrup is inside also. Okay, it's a good quality rasgulla. It's not like the local made or someone very incompetent has prepared that. If it is prepared by a good kind of the cook, definitely what you will find, each and every granule of the rasgulla or of the gulab jamun, or as you will just split the jalebi, you will find it's very juicy. The sugar syrup is inside to that. Was it only coated it on the surface? No. It was a bulk phenomena. The bulk of sugar syrup has been moved inside the entire gulab jamun or the entire rasgulla. Yeah, really, it's mouth watering, right? And especially, so this is the absorption. What is absorption? Actually, the word adsorption has been derived from this term only. Absorption, the basic term is the absorption, right? So whenever, right, one substance get inside to another, right, like the gulab jamun, like chai mein dooba biscuit ho gaya, right? So these kind of the things, if you take the biscuit, right? Okay, I'm having one biscuit and I'm feeling hungry also as I have not taken my breakfast. So if I take this biscuit, okay, I'm just going to dip it. What you will see that from the inside, right? Oh, so if I crack it, you will see that from inside, okay, this is soaked with water, right? Oh my God, now my hands have become sticky. What should I do? Oh, this is the absorption, right? The tissue I'm using is the best thing here. And along with that, this is one example of another. What you have seen that as I have soaked it in the black coffee, of course, only it is available in my room. So I just decided to take that also only. So when you have dipped it, what has happened? That and coffee has moved inside the biscuit. You can see it. And this is really has become the Ranveer Singh song "Chai mein dooba biscuit ho gaya." Right? So this is the story here. This is the absorption that has taken place. But I always prefer to have the bread butter in the breakfast. So what happens? Does the bread butter moves inside the bread? No, it is just spread over that. Like your favorite pizza, all your beautiful favorite toppings. Is it only? It's only for the top only. That's what its name itself is the topping, right? When you crack it, do you find the same feeling inside? No, the topping is not there, right? So this your favorite pizza is made by the adsorption process, right? Only on the upper surface, right? The seasoning and all the toppings are there. This is the adsorption process. Whenever on any solid and liquid surface, the other substance, it may be solid, it may be liquid, or it may be the gas, right? If it is added on any solid or liquid surface, this is the adsorption. Depositing, if it is deposited over, this chalk has been deposited over the green board. So this is the adsorption, my dear students. And when anything moves inside, right, when it goes to the entire one, right, when it is a bulk phenomena, each and every particle, right, it gets the other substance. I'm not using the perfect terminology just right now. I'm going to make you familiar with the terminologies that is used for this chapter, right? So adsorption and absorption, these are the two terms. Absorption is a bulk phenomena. It's not the surface phenomena, and adsorption is the surface phenomena that takes place, right, at the surface, at the interface of solid or liquid. I think you all remember the solution that two components are there. Here also the two components are there. One is the green board, and onto that only I am making the words or letters with the chalk. So this chalk piece is getting sticked over to this surface, on this surface, right? So this surface, right, one is the surface and other is the additive material, or that gets fixed over, or that gets deposited. In the solution, what happens? In the case of solution, one phase is intermixed into the another phase, and two components are there, solute and solvent. Similarly, here also two components are there. One basic component, and this is called the adsorbent, and the other is adsorbate. Please correlate it with the solution. Definitely it will be easier to remember the things. Adsorbate, right? Like the solute or solvate. Its pronunciation is like the that only. Adsorbent, it pronunciated as the solvent, right? The ENT is common in the spellings as well in their pronunciation also. So adsorbent is the other material that may be in the state of solid, liquid or gas that gets deposited. And adsorbate is the surface, right? The surface, right, on which anything is added, right? This is the perfect this green board is the adsorbate, this sorry, this green board is the adsorbent and this chalk is the adsorbate here, right? So two components are there. The basic component on which this phenomena takes place, right, that is present in the greater extent, in the greater amount, that is the adsorbent, and the second species that gets deposited, that gets stick over is the adsorbate. Solute, adsorbate, adsorbent, and the solvent. Similarly, for the absorption also, right? Two terms are used for its component. It's absorbent and absorbate. I think now you can understood it, right? I have taken one sponge, right? And now I'm just going to dip it. What you will see the phenomena. This will be the phenomena of the adsorption or absorption. If I'm taking sponge and I'm soaking it in the water, what it will be? This was my beautiful sponge, right? Now I have dipped it, right? So what has happened? Now it has become wet, so wet that it's difficult to hold, right? And I'm many times using this tissue paper here today for desorption process, for the process of desorption, the live demo I'm showing you of the desorption. We will discuss in the coming time, we will discuss the word desorption also, right? But basically you are getting the idea. That is, I think, my opinion, right? So this is everywhere, two components are there, adsorbate and adsorbent, right? The surface on which this phenomena takes place, this is the adsorbent. Similarly, here also, which is a basic substance, right? Okay, that is the absorbent. And what gets soaked here? Here, the sponge is the adsorbent and the water is the absorbent. So these are the two components, right, of adsorption and absorption, right? Understood? Absorption is a bulk phenomena, right? Always remember it with the rasgulla or gulab jamun. These are your favorite examples, and definitely you will never forget it. The reason behind using all these mouth-watering, tempting dishes is that you will remember the topic with this, and always remember the adsorption by the green board, blackboard example, because every day the phenomena you are seeing in your classroom, right? So many other examples are there. Sometimes you buy any of the cookwares, especially the water bottles, Milton, all these, you find some small packets. You buy the bags, luggages, right? Especially electronic devices, always a small pouch is there, and that is small pouch is of the silica. And what the reason is behind? All the electronic gadgets, they are always harmed by the moisture, and that silicone pouch is always kept so that it absorbs the moisture and the other gases there, and your electronic device is not damaged, it is safe. So many other, the nowadays we are using the mask, but the colliery persons, the persons who are working in the colliery areas, they were always working with the mask only, and they were having the charcoal powder into that. The reason behind that was the fine powder of the charcoal, it was absorbing the gases there, right? The gases which are harmful for the workers there, they have been absorbed by the charcoal powder, the fine powder that was there. Even the very simple example you have seen at your homes also, sometimes your mother puts some charcoal pieces in the fridge. Sometimes a foul kind of the smell is there in the fridge, and to remove that one, what happens? Your mother keeps small piece of the charcoal there. It's nothing superstitious, it's nothing religious, it's really a scientific one. The coal has ability to absorb all the kind of the gases, and that makes the smell of the fridge fresh, right? So I think now you have understood what is the concept of the adsorption. Adding up of anything, depositing of anything, retaining of anything on the upper surface, right? This is the adsorption. Whenever one substance moves inside, that is the absorption. It's definitely not a surface phenomena, it's a bulk phenomena, right? On the other hand, the adsorption is a surface phenomena, right? Only takes place at the surface. One question for the comparison, you have to compare between the absorption and the adsorption, right? The one very important, how you can distinguish? First thing, sometimes the question comes for the right differences or compare, distinguish. You write so many things, but you don't know actually how to answer these kind of the questions. Always the questions which are asked for the difference type of the question, always your first difference must be the criteria on the basis of which it is defined. Always and always. And please never count examples as the difference. No, it is always your support to your answer. 3 differences are to be written, 2 differences you wrote, and the third you have given the example. No, it should not be there, right? Definitely you will get the 2 marks for that answer. So these are some small tricks along with the teaching, the content I am telling you. So always your first difference must be the defining one, right? The basic criteria of the difference. Like this, what is the basic difference between the adsorption and absorption? It's a surface phenomena and it's a bulk phenomena, right? Now, one more point I just want to take here. What I did, I have just rubbed this part. I wrote something. That means it's a reversible one. I have written something. I have used a coffee and biscuit. So many things were sticking on my hand. And what I did, I have just taken a small piece of the tissue and I have removed it. That means it's a reversible one. I have reversed it back. I have removed, once the things were deposited on my palm, my fingers, now with the use of the tissue paper, that has been removed. It's a reversible phenomena, absorption and desorption. Desorption means removal, right? If I just rub it, this is reversibility. But if once the rasgulla is made, it's soaked with the sugar syrup. The sugar syrup has moved inside. Is it possible? No. Gulab jamun is going to be broken, right? So don't do this experiment. Otherwise, your mothers, they are cooking with the great effort nowadays during this lockdown session and these sessions, they are going to beat you. So definitely at this time, you have understood it's passing surface phenomena, right? I'm just going to distinguish in the very short. It's a surface phenomena. And this is a bulk phenomena that takes place in the bulk, right? It's a reversible one. But it's not reversible. It is irreversible. One very important thing, adsorption is always an exothermic process, right? And there is no concept of the energy change. It's not a hard and fast that either it is a exothermic or it is the endothermic phenomenon. No, there is no definite concept. There is no criteria, okay, for this to take place, right? Just in the few minutes, I will tell you how it's an exothermic phenomena, right? So this is the basic difference between how the adsorption is different from the absorption. Surface phenomena, bulk phenomena, right? Irreversible, and this is the reversible one. Exothermic, maybe endothermic, maybe exothermic, no definite criteria for the energy concept. Okay, guys, shall we move to the next topic of the same? Continue, kare? Yes. Okay. From the very long time, I'm saying deposition, deposition, deposition. But why this happens? Why this takes place? What is the reason behind this? What is the mechanism of the adsorption? Right? What is its mechanism? Mechanism, I think now you are familiar with this term. The last chapter, so many times I have used this term of the mechanism. Here is one small picture. I think you can see this. What is there? There is simply one vessel is there. In this, something is filled and one particle is at the center, right? This particle is at the center. What do you feel? That this will feel this is surrounded from all the other side by the other particles, right? From the upper side, from the left side, right side, from the every side, it is surrounded by another particle, right? That means everybody is pulling towards itself from all the different sides. The force is applied here. This force may be a physical force, this force may be a chemical force depending upon the nature of the adsorption. So it is stable. If suppose someone is pulling you from the left side and other is pulling you from the right side, what will be the result? You will be in the middle, you will be these forces will be balanced. So here the particle that is at the center, it feels always the balanced force. But what is the story for the surface particle? Here, see this, right? This particle, right, from the lower side, this side, the force is being exerted onto this. But this part, no force is applied here. That means definitely unbalanced force is exerted over the particles the particles which are at the surface. The particles which are at the middle part, from all the sides, the equal force is applied. But here the force is not equal. Like here, it's a theory chapter. Some of you must be thinking better to go. But another time, as your eyes are blinking, you all think, what? No. Better, I should understand. This time may be utilized. Otherwise, this time will be wasted. Some of you people will be thinking, oh, best thing is I should go for a breakfast, something like this, like this. But on the other hand, when you come to the importance of the learning, you sit again and you start learning, right? But if one force, that is if you are very hungry, definitely the other force will be unbalanced one. So similar is the story here. The particles which are at the middle, they feel the balanced force, the balanced force from all around is exerted onto that, but from on the particle that is at the upper surface, right, unbalanced force is there. If the force is unbalanced, that means definitely they are unstable, right? And they have the higher energy. Please listen here. Now I'm coming to the thermodynamics also along with this. What will, if something is added, that means definitely some or other kind of the bond is going to be formed, right? Whether if it is the physical van der Waals force, if it is chemical, it will be ionic or the covalent bond. But every bond formation process is the exothermic process. Always and always the bond formation is linked with the release of energy. Now they are in the higher energy state, and always the higher energy state, they are feeling, they are experiencing the unbalanced force, right? This unbalanced force make them unstable as they have the higher amount of the energy, right? Energies are more, right? Here, pushing, pulling, pushing, pulling, pushing, pulling, the energy is balanced, right? But these particles, they have the extra amount of the energy, and how they want, they just want allow someone, okay, to get added here, right? And by this, a bond will form at this intersurface. This bond may be the physical bond, like the van der Waals force, or it may be the chemical. And on the basis of this bond only, on the basis of the nature of bond, this is divided into the two types, or the classification of the adsorption, the types of adsorption. There are two types of the adsorption, physisorption and chemisorption, physical adsorption and the chemical. Here, since the bond is formed, now what happens? The energy is now liberated, right? From the upper side also one species has counterly attached with it. So it is now experiencing the balanced kind of the force. And this is the reason why any surface allow the adsorption process, right? In the very short, I am concluding this. Surface particles have the unbalanced force, right? And unbalanced force are, because of the unbalanced force, they are having the high amount of the energy and they are unstable. And for that, for every phenomena in this world is for the stabilization process. Always and always everything revolves around so that they can become stable. So these particles also want to become stable, and for this purpose what they do, they just combine, they just allow someone to add with them, right? If they are added, that means adsorption has taken place. How they have added? On the basis of this, right? This may be a chemical bond, this may be a physical force, right? It is of two types, physical adsorption and the chemical adsorption. Clear, guys? I think, have you understood? Please tell me, have you understood the phenomena, how this process takes place? Now I am going to take its types. What are the types of the, and this is the most important question that is asked from this topic, right? One is the first one is the physical adsorption, also known as physisorption. And another is the chemical adsorption. Known as the chemisorption. है भाई, क्या है? एड्सॉर्प्शन ही है, बस बॉन्ड्स का डिफरेंस है और उसी बॉन्ड्स के डिफरेंस में इनका नाम डिफरेंट है. नथिंग वेरी बिग, राइट? Adsorption, if it is by the physical phenomena, it's the physisorption. If chemistry has been involved here, that means it is the chemisorption, it is the chemical. Everywhere, wherever the chemical or chemistry will be involved, the bonds will be formed definitely, and these bonds will be the either covalent bond, mostly this is, or ionic. These are the two kinds of the bonds generally which form. And here, the bond that is present between the adsorbent and the adsorbate, this is the van der Waals force. Guys, which one is the weak one and which one is strong? Van der Waals or covalent? Khali and a normal guy, who will be the stronger? Definitely the Khali will be stronger. So Khali is this, right? This chemical adsorption, this covalent bond or ionic bond always is stronger than the physical force, that is the van der Waals force. The adsorption when takes place by the van der Waals force, right? This is the physical adsorption. Whenever the adsorption takes place by the formation of the covalent bond or the chemical bond, it is the chemisorption or chemical. One more term is the sorption, SORPTION. Anybody knows? When both the things takes place simultaneously, absorption as well as adsorption, right? That time the term sorption, SORPTION, is used, right? So here, balushahi, the sugar is coated on the surface as well as you break it from inside also it is juicy, right? So this is perfect example of absorption. The kitchen is having the all examples. Now first I am taking the physical adsorption. What are the factors that on which it depends upon how this takes place, right? Now I am just doing one thing, you just tell me, right, what I did. I have just rolled one green chalk here, right? Then pink, but this also I don't like, okay? It's not a beautiful color that can be very apparently seen. So what I am going to do here, I am going to use one yellow onto this. But as usual, the favorite of the teachers, that is the white one. Okay. What you have seen? How many layers are here? First layer that I have deposited, that means the first adsorption that has been taken place is for the green chalk. Then on that, pink, yellow, and then the white. That means multi-layers are there. That means it's not only for the one time, that sometimes you paint your house with some color, but you feel that it's not beautiful color. What do? You just change the color. On that only the new emulsion is deposited, right? That means physical adsorption may be multi-layered, right? What may be? It may be multi-layered. Now, every day this is taking place in the school, in the class, even during the teaching. I am so many times did. Today itself, I have removed this. Right? This is reversibility. It's reversible, right? The physical adsorption is reversible. During any of the phenomena, some energy of activation is required. Since the van der Waals is the very weak kind of the force, the energy that is required is very, very less. And that's why, and earlier also I told you that it is an exothermic phenomena. The energy of activation that is required is very less in comparison to the heat or the energy that is given out. So what do you think? Just think about yourself whether if you are going to increase this the temperature, this will promote to this or not. No. Definitely the heat is not required for this. Generally, if you increase the temperature, the rate of physisorption gets decreased, right? And one very important thing that I want to discuss, the factor that affects to the physical absorption, it is the nature of the substance, right? 3, 4 gases I have, right? And they have different critical temperature. Dear students, the word critical temperature you have studied at the time when you are studying states of matter in the class 11th, liquefaction of the gas. I'm just reminding you, the gas that has a higher value of the critical temperature is easily liquefiable. That can be easily converted into the liquid and easily can be absorbed also. So if a question is there in the NEET or the any kind of the exam, especially competitive exams, they ask this kind of the question. They give 3, 4 gases and their critical temperature is given, right? Which gas will be more effectively absorbed, right? Likewise, or sometimes they give the sequence to arrange them in the correct sequence of their absorption. So what is the key factor? How you can find the answer? You need not to go for a very long kind of the explanation, right? The very thumb rule that will work here, higher is the critical temperature, the gas will be easily liquefiable and that will be the easily absorbed also. Right? If I compare the hydrogen and CO2, SO2 is always the most effectively absorbed as it has the highest critical temperature. Right? So these are some, and of course, the physical absorption will depend upon the surface area as the phenomena itself is the surface phenomena, right? So surface area greater, definitely the absorption process will be greater, right? So this is the physical absorption. Whenever absorption takes place by the formation of the van der Waals forces or the physical forces, what it is called? It is called the physical absorption. It is reversible phenomena as the physical forces are involved in this, right? Less amount of energy is required. Multi-layer, you have seen on one over another I have deposited the layer, right? So all these things are possible for the physical absorption. Whenever absorption takes place by the formation of van der Waals force, this is called the physical absorption or physisorption, right? Absorption ही है उसी का type है. Now I'm coming to the chemical absorption part. The chemical absorption, right? It is the phenomena of formation of the chemical bond, right? And the chemical bond, you all know that one very important parameter is here, the activation energy. Although here also, this is also, please don't have a confusion. This is also the exothermic process, right? It's exothermic in nature. But as you know, for the beginning of the reaction, at the starting of the reaction, what you need? You need some energy of the activation, and this energy of activation is always high. So by increasing the temperature, its rate become faster one, right? Now, if I am going for the reversibility factor, what you see that this is always accompanied by the formation of chemical bond. That means what happens? Compound is formed, right? And if the compound is once formed, it's not a reversible phenomena. It's an irreversible phenomena. And do you think multilayering is possible? No. Actually, what happens in the case of chemical absorption, it has free valencies on. Okay, suppose the nickel is there, right? Nickel, it has 4 valencies. Okay, 3 valencies, they are satisfied but this fourth was the empty, right? Another substance came which has the suitable valency, right? Here, now what has happened? This valency has been completed, this has been satisfied, right, by the formation of bond. So why it is going to be reversible now? Its valency was one left, that was not accompanied by any of the group. Now it has been satisfied. So definitely and definitely, right, now it's not going to break its bond, right? It has become to the stable, it came to the stable state, it has made the bonds, right? So definitely now it's stable, it's not going to reverse the phenomena. So it is the irreversible phenomena, right? The one thing that is the very effective one always is the nature of the compound. Here also, if they have close affinity, that will be definitely have the faster chemisorption rate, and which is not having the affinity with the surface, that will definitely be there. And here only one layer will be formed. If this valency is satisfied, do you think one more layer it can deposit? No, because why? How it has to deposit? The layer that is going to be deposited or retained here by the formation of chemical bond, it is not having the free valency. So how it will combine? Any bond, it always takes place by the free valencies. Only one free valency was there on the upper surface, okay, and that has been already fulfilled now. Now it's satisfied. So definitely this is not going to be reversible, right? It is an irreversible phenomena, right? The physical adsorption is the reversible, the chemical is irreversible. And of course, the greater is the surface area, greater will be the chemisorption. Any surface phenomena that depends upon the surface area will be always facilitated by the larger surface area, and that's why all the reactions, all the adsorption process that takes place better in the powdered form. That's why in the masks also always charcoal, rather than the charcoal piece, charcoal powder is used, right? So these are some points that help you in understanding of the chemical and physical adsorption. Just go for a quick comparison. One very important question for the 3 marks. That's why I'm giving you this hint. Sometimes a 3-mark question is asked on this only. The comparison between the physical and chemical option, right? The first point of the comparison is this is always accompanied by the formation of the van der Waals force, right? While on the other hand, the chemical adsorption is always accompanied by the formation of the covalent or ionic bond, any bond that is a chemical bond, right? It is reversible. It is irreversible, right? It is single layer, multi-layered, right? You have seen one layer, right? Another 2 layer, right? So this is a multi-layer phenomena. This is a monolayer phenomena, right? The enthalpy of the physisorption, the correct term that I must use as a science teacher or chemistry teacher, the enthalpy of physisorption is less, 20 to 40 calorie, and here definitely since the bond formation is chemical bond, its enthalpy is greater, mostly 200 to 400 kilo calorie. That is the value of the enthalpy, right? Then some properties are common also, right? Reversibility, irreversibility, single layer, multiple layer, energy. Then the effect of heat will be also, this will always, by the heating, what happens? It always and always slow down. That is always facilitated, its rate is facilitated One factor that is common in both of them, they depend upon the nature of the adsorbent, right? And definitely the second, the surface area. By increasing the surface area, both the physical as well as the chemical adsorption increases. So guys, this is all for the today, right? What are the things we have studied today? What is the adsorption? What is the absorption? Then mechanism of the adsorption and the types of the adsorption. Next class, I will take on the Friendlich adsorption isotherm, and I hope you all have understood the topic and we will continue our learning. Thank you. Have a nice day.